Okay, is everyone here? Can everyone hear me? Okay, good stuff. Well, my name is Ian Quist, and I'm the current maintainer of the Farseer physics engine. And I'm going to talk a bit about how to build games for Windows Phone 7, 7.5. And we are also going to take a look at something awesome, something called the Farseer physics engine. So let's start up. The first thing we're going to take a look at is XNA. How many of you know XNA? Hands up. Okay, that's a good amount. Not everybody, that's good. These games are built for the Windows Phone 7. They might not be built in XNA, they might be built in C++, but they could have been. And that's really what it's all about. It's about building games. XNA is a game framework. You could also build applications, but we have Silverlight for that instead. It's much more easier to build applications in Silverlight than it is in XNA. But these games are all fun, and I bet some of you have played some of these games, or perhaps all of them. And it's a big market, and Microsoft makes it even easier to build games than it used to be. So that's XNA. But the XNA framework, what is it really? Well, it basically is a high-performance game framework. It gives everything you need, from math to graphics to audio, even a content pipeline that converts your data. All of this technology is packaged into one library for you to use, and it's all free. You can use it for 2D games, you can use it for 3D games, you can even make a mix of those, make a 2.5D game if you want to. It has a rich content pipeline, and we're getting a little bit more into the content pipeline later. But that's not enough. If that's not enough, we have this framework for the Windows Phone 7, the Xbox 360, and the PC, all in the same framework. They have made it easy for you to convert between these three platforms. The same code runs on different platforms, and they run exactly the same. If we take a look at how the XNA framework works, this is a bit of code in the XNA template. What we see here is an update loop and a draw loop. The update loop is where you update all your logic in the game, AI, network, physics, particles, input. All of this is running 60 frames per second, 30 frames per second by default on the Windows Phone 7. In the draw loop, we can draw all the stuff that we need to be seeing on the screen using textures. And that's also running 30 frames per second on the Windows Phone 7. Now this might seem trivial. It might seem, okay, we can do that with a timer. But that's a big chunk of logic behind this. And they made it really, really simple for you to control these loops. By, for example, okay, I want to make a variable loop instead so that it runs as fast as possible all the time. You can do that with one line of code. So they made it really easy in the XNA framework for you to use. But not only that, they also have included media such as music, photos, and video. They, for example, made it possible for you with 3 lines of code to play a song from the internet. You simply give it a URI, and it's going to play it right away. It can loop the music, it can put pitch on the music, it can do what you want to as easy as possible. Or you can load a graphics file, and you can save it using the media library. All of this, again, with a few lines of code. That's important when it comes to gaming, developing games. Because we need to be developing games instead of sitting around and make boilerplate code. We need to think, be creative, and create the game instead of sitting around and make solutions for all the problems that we have had the last 20 years. But Microsoft made solutions for these, and they gave it to us. And that's great. Now, I said we'd come back to the content pipeline. The content pipeline manages assets in Visual Studio. It's directly integrated into Visual Studio. It's going to create a project, a content project, where you can drag and drop all your data For example, images, WAV files, MP3 files. And it's going to convert these chunks of data into a more efficient format for you to be loading into your game. It's important that when the game loads up, it loads up quick. And when it uses these assets, it's going to have them in a format that is easy to use in the game. So what XNA does is that it converts these images, MP3s, and data in general into a format that you can read using the content pipeline. We also have inputs in XNA done easy. It used to be a little bit harder. It used to be, okay, have a keyboard here, I need to map the keyboard, for example, I need to know when an A is pressed. In the XNA framework, this is really, really easy. And they extended this so that you can also use the inputs from the Windows Phone 7 touched. You can even use gestures. You can use an Xbox 360 controller. You can use a mouse, you can use a keyboard. All of these inputs are consumable in an XNA game. Sensors are also one of the very advanced features that are easily consumable in XNA. For example, you need the phone to vibrate for 5 seconds. Well, tell it to vibrate for 5 seconds and just does it. It's that easy. It's important to use stuff like vibrators in games for Windows Phone 7. For example, an explosion. Well, we need to vibrate so that the user is more engaged in the game. And this is really, really easy to do. As you can see here, it's one line of code. That's it. We can also use some of the other instruments inside the Windows Phone 7. For example, it has an accelerometer that you can measure what the orientation of the phone is. So when you tilt it, something different happens in the game. These are consumed using an event that gives you all the data that you need. It's really easy to read, but it's sort of tricky to read it while you're trying to update objects in the game. I'm coming to that later. But XNA, in summary, is really, really powerful. It's simple to use, it's easy to use, and it's very, very powerful in the sense that it's efficient. You don't need to optimize XNA, it's already optimized beforehand. And it even has support for something called SIMP, which is an instruction set on the CPU that you can use using vector graphics, vector operations, vector math. And it's going to speed up all your math automatically by 20%. All this stuff is included inside the XNA framework. Easy consumable and it's free. It's included in the Windows Phone SDK on the create.msdn.com website. But enough with XNA. Let's take a look at what I'm all about, and that's physics. Now, I might sound like some of your teachers in school, and I'm not boring like that. I don't mean physics like this is the angular drag math, and I'm going to look through that. No. When I'm telling physics, I'm telling game physics. And people have been using our engine all over the world in products that some of you might have installed on your Windows Phone 7 or on Xbox 360 or PC. So far, we're up to 8,000 downloads each month. That's a good amount. It's not high enough, but it's a good amount. We have had 200,000 downloads so far. We have had almost 500,000 visitors to our site. People that want to take a look at the Farseer physics engine just for fun because it looks interesting. Have in mind that these guys are developers. They are not the consumers. They are not the guys that buys the products. They are the guys that develop the products. Now we have seen this physics engine used in many games. Some of them really interesting, some of them really known. You might know Crashlander, for example. It's developed by Jeff Weber. He's the original creator of the Farseer physics engine until I took over the project. We have Gerbil Physics, we have Star Ninja, and these are all runnable on the Windows Phone 7. We have games on PC, Ninjas, for example, Square Off, Gymnast, Superspace, and Superspace 2. People are using this engine all over the world in different kinds of platforms. Even on Silverlight. That's right, Silverlight. we can run this physics engine inside Silverlight. We could create games such as Bus Launcher, Tirestorm, or Drop It Well. These are games that you can run online inside the browser in Silverlight. Now, not only that, but I see people use this on Microsoft Surface. It gives an interesting twist to use it on something like Microsoft Surface. Imagine it. You touch around the screen and stuff follows your hands. But not only that, I've seen it on bar counters. People going to a bar and getting a beer, and when they place the beer, a beer pops up on the screen on the bar counter. And they can swipe the stuff on the screen, and they can collide stuff on the screen. All of this is done using Farseer Physics Engine. But then again, I was surprised because some guy came to me and said, "Oh, hi, I have a kid at home, and she's playing with the refrigerator. It has a touch screen." So I thought to myself, why not convert Farseer so that I can use this on the refrigerator? I was like, you're using Farseer on the refrigerator? Very interesting stuff. But I was surprised once again when some guy came to me and said, I made a 3D game using your 2D engine. Not only a random 3D game, but Toy Stunt Bike that I was inside my Xbox 360 running through all the top downloaded games, and I saw the Toy Stunt Bike, as you can see in the screenshot. So I was pretty surprised that a guy using a 3D graphics engine can use a 2D physics engine. But that's the power of it. It's up to your imagination to create games that are powerful, that are different than the games out there. And you can make a lot of money on it. So what do all these games have in common? Well, first of all, they are built in Farseer Physics Engine. Second of all, they use physics. These are simulating real-world physics. That means when something drops, it drops under the influence of gravity. It has angular drag, it has linear drag. And all of these properties together in a big bundle of math, it's going to make these games look really, really realistic. It makes a new twist to the game that have not been seen before. Some of these games are old-timers. Some of these games are based on old games that we all know and love, but they made a new twist to it by implementing a physics engine, make it more fun. So, all in all, what is a physics engine? Well, I'm taking a screenshot of a game here called Gymnast. It's built by a guy called Valiber. He makes his own physics engine, but he decides to use ours in his game here. Now, all of these things on the screen right here is what we supply with Farseer Physics Engine, okay? We have efficient collision detection, so you don't need to check when things hit each other. It just happens. It's natural to us that when this bottle here hits for example, the window, it's going to bounce off and fall to the ground. That's natural to us. But that doesn't happen automatically in games. But it does with a physics engine. Not only that, but you can define gravity, you can define friction, you can define restitution. That is what happens when stuff falls to the ground. How high does it bounce back? How much energy is preserved? That's restitution. We have angular drag, rotational drag. We have linear drag. That's, for example, when stuff is moving, it's a drag on it. We have moment of inertia and even more than that. We have a billion things inside this engine, and all of it is calculated automatically for you. But we can do more than that. Okay, this is a big package. This is very flexible. You can do this stuff on the screen right there, the screenshot of this bouncy thing. It's actually really bouncy. We take a look at that later. But it's created using these few lines of code. Nothing more to it. You just tell what you want, and it gives it to you. You can use this to create change, bridges, grappling hooks, whatever it comes to mind. And I've seen these things being used as tank tracks, for example. And I'm really surprised how people are using this stuff. But then again, I have a limited imagination, and people are very creative. So sometimes I see stuff that I did never have no imagination of that. But then again, we could go further than that. We can do polygon manipulation. We can cut polygons. For example, this is a laser demonstration where I've made a pyramid and then cut it in two. This is one line of code. We can go further than that, and we can take complex polygons and we can combine them together. All of these tools are to be found on the internet in different packages all around. But we're taking all of these, make them better, make them faster, put them inside the XNA enable framework so that you can use XNA properties and stuff like that inside the algorithms. And we include them in the package. So get all this for free. But enough presentation of that. Let's take a look at how we actually use this stuff. And to do that, I've prepared a couple of demos using XNA first and foremost. So we take a look at the first example here. Start out with XNA. And for those of you who haven't looked at XNA before, this is all gibberish. So I'm going to take a quick glance at it and tell you how stuff works in XNA. Now, the first things you see here is that we actually inherit from game. Game is the base of XNA games. And inside that, we have all our logic inside here. So we create a graphics device manager. We create a sprite batch. The graphics device manager is direct API to the graphics device. You can ask it how big is the screen, for example. The sprite batch is it's sort of a higher level API to draw graphics onto the screen using 2D textures data. It's an easy way for you to draw data on the screen. We have some textures here. We have a single texture, sorry. We have something called cheese texture. And we have a vector too. That's a position where we're going to draw this cheese. Now, XNA has some default methods that's going to be run. One of them is initialize, and that's the first one to be run. That's where you put all your initialization coding. So I set the cheese draw position just to the upper left corner, and that's important to know that 0.0 is the upper left corner. The next one is draw content, and load content, and that's where we load all our content. It's very logical. And that's where we put in the loading of the texture. Here we are actually inside the load content. We're actually using the content manager. That's called content. It's a property that we can use. And has a load function that loads in the graphics. Now have in mind that my content inside the project, for example, if you go over here, we have a content project down here. I hope you can see it. And we have a PNG file. But when I load the file, I omit the .png. I do that because all the data in the content pipeline does not have extensions. They are all converted to the same data format. Now the next one is update, and this is really where all the fun stuff happens normally. This is where you check for the input, and Microsoft has been so kind as to put in a exit function that we can call using the Xbox 360 controller. It's just an example of how you can do input in this update function. And the next one is where the most of our stuff happens at the moment, and that's where we tell the sprite batch to draw out a texture on the screen. Now if you run this guy here, I run it in the Windows Phone 7 emulator, because it's Windows 7 camp, right? And that's what we get. We get a red ball in the upper left corner of the screen. It's as simple as that. That's what's needed to get something to draw on the screen. Now you might think, okay, I have Silverlight, I can just drag and drop this thing on the screen, and it just happens. But this guy here, right here, you can do everything, absolutely everything you want with it. So that's the first sample. We'll take a look at the next one. We let the emulator run in the background, so my computer's kind of slow. Next one, we have put some extra features on it, and let's just start it up and have a look at it. Oh, awesome. Let me hit the right button. Okay, so here I've done two things. First of all, I've changed the orientation of the screen so that it's different. My mouse is acting up, sorry for that. And I've enabled it to do the Windows Phone 7 gesture called flick. So I can take the mouse in the sample here and I can flick it just as if you would on the screen on the Windows Phone 7 device. And the ball bounces around. Have in mind that the ball is contained within a rectangle. That's logic that has been put in the sample that makes sure that if the ball hits the border of the screen, it's going to reverse and bounce back. So how do we do all this? Well, it's an incrementation of the sample before. So we have the same texture, we have the same cheese draw position, but we have two more properties here called cheese position and cheese speed. And we put in some friction. These properties and these fields here we're going to use later. Now the first thing I said was that we changed the orientation. Now on the Windows Phone 7 we can change the orientation, or we can tell the device what kind of orientation we support by using the graphics.supported orientations property. And we can even all the different orientations. So I tell it, okay, I want to support portrait and I want to support the default orientation. And it's going to combine those and tell the device that's what we support. This is important in games where you only support one orientation, for example. Now, I also need to tell it what kind of gestures that I need to enable. And I just said, okay, we need flick. And flick is, again, it's this gesture right here. The same load content, but we have more stuff inside update. Now, here we put sort of like physics in it, right? This is 3 lines of physics engine. This is where we change the position of the cheese, and this is where we change the speed of the cheese, because we put some friction on the speed so that it slows down, it doesn't keep going all the time. But really the important part is here where we tell it to change the speed of the cheese using the gesture.delta value. So it's one line of code to enable us to do this flick motion. And again, we need to tell it to stay inside the screen. So we put some clamping on here where we tell it, okay, if the position of the ball, that's the upper left corner of the ball, plus the width of the ball, is hitting the side of the screen, well, you should go in and do this stuff right here. And we have the same draw down here. So as you can see, we extended this sample with a lot more stuff just using a few lines of code. It's really simple. It takes 10 minutes to create this sample. Now the next one, we're going to take a look at how to implement reading the different sensors in the device. So if you start it up, deploy it to the Windows Phone 7 emulator, we can go in and we can change the orientation of the phone inside here. Let me see if I can get both of them on the same screen. So if I change the orientation of the phone, it's going to make the ball bounce in another way. So it's reading the sensors on the phone and it's using it in the game. We create really fun games using this stuff. But how do we do it? Well, same sample as before, but we put some new stuff inside the initialize, and that's where we initialize the accelerometer. We need to go in and we need to apply ourselves to the event called reading changed. And that's where stuff happens, since I here. Now have in mind that this is an event, and the event can be run at any time. So we need to lock the reading of the event so that we don't come into concurrency issues. So we're locking it and we're reading the data. The data is stored inside reading, auxiliary reading, and we simply, if you go down to where we use it, put it in. Where have I put it? Sorry. Oh, I thought so. Put it in here. So inside this lock, again, we need to lock it before we read it. And we change the acceleration using this value that we got from the accelerometer. So we can actually combine all of these inputs. We can have flick, we can have the accelerometer, and we have created a game. It's that simple. Now, it's not a very fun game so far. It has no history in it. It has no great graphics or sound and stuff like that. So why not put sound in it? As I said before, we can include sound using the content pipeline. So we have a pop.wav file here, and just drag and dropped it into the content pipeline. It's converting it into the XNA format. So it's the same sample as before, but down here inside where we hit the borders of the screen, we put pop sound of play in. And that's, sorry, I'm scrolling a bit here. And that's a sound effect that we have loaded using the content pipeline. So when you start up the demo, it's going to deploy to the Windows Phone 7 emulator again. We can hit pop. Let me. I am. It's just very low. Okay, so going crazy now. There we go. So let me start it up again. Geez, roller. So it's that simple. Just putting in a sound makes it a lot more fun. Makes people wake up. And I'm not going to have that running in the background. So that's some very basic examples in XNA and how we can leverage the powers of XNA using only a few lines of code. It's rapid game development, guys. This is where the powers of XNA comes in, right? It does all the math for us, it does all the drawing. We don't have to think about how stuff is drawn to the graphics card. We don't have to think about it's all triangles and need to be in the right order and stuff like that. No, we just draw it. It's that simple. As it should be. Now, I've made a sample too. I made a small sample in XNA. And this sample, let's run it. It's not running on the Windows Phone 7 because it's tedious to run it in an emulator all the time. So you might as well make it enabled on the PC and then convert it to Windows Phone 7 and run it there. But this sample draws two elements on the screen, and the elements are movable, or the circle are at least movable. And it's a really, really simple sample. Just to take a look at it. Now, as before, we have the two same things here. That's from the XNA template. We have the two textures, and we have some positions, just as before. Now we load all the stuff in here inside the load content, and we position the circle in the center of the screen. Now the center of the screen we can calculate using the graphics device. As this viewport up here, that tells us how big is the screen at the moment, where are the boundaries, and we can find the center of the screen. So I draw a circle there, and I take the center of the screen and offset a rectangle 100 pixels downwards. Have in mind that plus 100, it's down on the XNA framework. Inside update, we handle the keyboard state. We change the position of the circle and using just vectors and 1 pixel at the time by checking if the ASDW key is pressed down. It's that simple. Have in mind that this update is running all the time. It's running 60 times each second. So when we press down the button, it's going to do 60 pixels per second of movement. It's ordinary math. And inside draw, we do a little different than before, because we're going to draw using an origin. We're going to draw the circle by centering the circle first. It's a little bit tricky here. So that's basically it. But what if we took something like the physics engine that I built and we put some natural physics inside the sample? Because what would happen if I put physics on this? Well, the ball would fall to the ground down here and it would bounce up again. And when instead of moving it like this, it's very boring, right? We can move it in a different way. We can, for example, rotate it instead. So what's needed for this sample to run in Farseer physics engine? Well, let's take a look at it. This is where things become fun, right? This is where we can use our creativity. And this is what happens. So I can roll the ball, I can jump the ball, and it's all using the same code, but I made it physics enabled. So it's that simple. Well, at least in theory. Let's have a look at it. So in order to use Farseer physics engine, we create a world. Now, we are living in the world, so that's obvious. But you can have zero world inside Farseer physics engine. So you can have a background world and a foreground world. And they can be simulated independently. Inside the world, we put bodies. We have one body for the circle, and we have one body for the rectangle, the ground. Bodies are just point in space, just bitty points. And they are movable by gravity, for example. So we can apply gravity to them, and these points move. Now, to these bodies down here, as you can see, we just ordinary loading of the textures here. Now, but to these bodies, we use a body factory. It's something in Farseer physics engine that makes it really easy to use. I just tell it, I want a circle, I want it there. It creates a circle and creates it there. It's awesome. But it attaches what's called a fixture, a shape to the body. So a body is a point in space, but a fixture, together with a shape, makes a circle at the center. With the center, the body as a center. Now, we can use some properties on these. We can put friction and restitution on them. So this is restitution. That's the amount of force coming back to the ball. That makes the ball bounce a bit. So I say, okay, 30% of the energy that comes to the ball is coming back. So as you can see, when I jump, it bounces a little back. It has some friction too. It has actually 50% friction. So when I run the sample, and I, for example, jump, I can see the friction at work. So these are adjustable, and we can make some really fun games just by, for example, switching this to 1, not 2, that would be the same, and the ground to the same amount of restitution, and run it again. And we have a bouncy ball. Now, people are going crazy with this. They say, okay, let's try 200% and make a rectangle that this ball is inside, and just goes crazy, and it gets faster and faster, and then stuff breaks. Okay, now the tricky thing about Farseer is this line of code here. We're using something called meters in pixels, and that's a constant that I will set up here, right here, to 64. And that's because Farseer physics expects the values to be in meters, not in pixels. So 1 meter in the real world is 1 meter in Farseer. But because it's 1 meter that we define, then how long is 1 meter in the world? Well, it's 64 pixels is that. We just set it to 64 pixels. The reason we are doing that is because Farseer is faster when it's using small values. It's more stable when using small values. And we have the ability to make the graphics independent from the physics engine. So we can have a camera that moves and zooms out and in without the physics being disturbed by this. So we obviously, inside update needs to update the world. We tell how much time has passed since the last time you updated. So you can actually make something like a speed up of the simulation. Stuff happens faster by giving it a higher value. Or it happens slower. It could happen in slow motion by giving a lower value. And inside handle keyboard here, It's exactly the same as before. Yeah, we have a question here.
Is it possible to actually slow down some of the objects or some of the bodies?
Yeah. So the question was, is it possible to slow down some of the bodies? For example, having a slow motion effect on some of the bodies. The answer is yes. And that's because you can apply drag and you can subtract from the forces applied to some of the bodies. So it looks like they are in slow motion. Okay, so before we were moving a vector, we were moving the point in space that the circle was at. But now instead we are applying torque to this circle. And that's all handled by the engine. So we apply -10 in torque. And as you can see here, hopefully, that should be, it should have a unit. Sorry about that. Okay, and we apply, when we press space, we apply an upward force to the circle so that it jumps up. And that's called an impulse. When we jump, that's an impulse. But when pressing something, that's a force. So that's the difference between the two. So I'm applying an impulse here. I could just as well apply force. So that's what's needed to make all of this work. But we need to draw it correctly too. So inside the draw method, we're converting from the physics world again back to the graphics world. That's a conversion between the two, the meters per pixels. And it's just as simple as going in and take the circle position that we have times meters in pixels, and then we have the real circle position where the circle should be. Okay, for some of you might think, oh, that's too much work for me. But if you sit down 10 minutes and you look at this, you see, okay, it really has its advantages. We have the ability to make a camera, and let's be honest, games have cameras, right? You can zoom, you can move the world. So it is important to have this stuff in there. These samples will be uploaded to my website. I'll be giving you later. And they are also available on the Farseer Physics Engine homepage. Okay, so that's a simple example, but we can also run it on the Windows Phone 7. Again, that's the power of XNA, right? We can run the same game inside a Windows platform and can run it in the Windows Phone 7 platform. I told it to run on my device. Let's run the emulator instead. Let's start up. Change the orientation. There we go. So the same code runs the same way on the Windows Phone 7 device. It's important to note that, because when you run stuff on the PC and you convert it to to PlayStation 3, they are not going to run the same. But they are in the XNA framework. That's brilliant. Okay, so the real powers of Farseer Physics Engine is really only shown by the physics displayed with graphics, right? So I've taken the samples on the homepage, the Farseer Physics homepage, and I'm going to run them here. And for that, just for fun, I've taken my Xbox 360 controller, sorry about just the Xbox controller, put it in, and hopefully it works. It does so far. And let's have some samples. So I need a volunteer. Do one of you want to handle the Xbox 360 controller? It's really easy. It should be come natural to you. So try clicking on the first one. Yeah, try it. Try the lowest button. Yeah, lowest button. Blue one. Sorry, green one. There we go. Okay, so you can use the input from the Xbox 360 controller. You can consume it using the XNA framework. And all the drawing here is done with XNA too. So what we've done is that we're taking Farseer Physics and we have put a rectangle in it and physics enabled it, and we removed gravity so that it floats around. So when it hits the wall, it's going to bounce off, but we're taking off some of the bounciness so that it looks like it's a box in space. If you go back, that's the button to the left of the middle button, the white one, right there. Right there. Yeah, there we go. And then you can take the third one from the top, multiple fixtures. There we go. So he's new to the Xbox 360 controller. It comes quite natural to him anyway. Yeah, and click again. So the sample starts up, and this is an example of how we can make bodies static. You know, not much of the world needs to be movable. For example, the terrain that you're moving on should not be movable itself. For example, Mario would be crazy to play if all of it were in there. So you can control this agent, we call it, using the mouse alone. And it's actually attaching a piece of logic to the agent so that you can drag it around. So it's not following the mouse in a very rigid way. It's following the mouse with a bounciness to it. That's natural. It's like hooking on a chain to it and dragging it along. So if you go back, he's having too much fun. Yeah. Take the stacked objects, and then he can have more fun. So you can actually move the agent using the other thumbstick on the controller there. The other thumbstick, the gray one, that one, yeah. And has a really high force to it, you know. So yeah, he's going to destroy stuff now. And again, this is a simple sample, but people right away recognize it as a game. This is just a tech demo. It took 20 minutes to make all in all, because I need to make all this pyramid happen. He's having fun. So try to go back, and we can show some of the more advanced features. So if you take the dynamic angle joints, yeah, that's right, that one. Okay, this is an example of how we can use joints. These guys actually close when after some time has happened. These guys close. As you can see now, he's broken the simulation actually. But that's how it works in games. Sometimes you get what's called tunneling, and that's what's happening here. You can actually turn off some features that would prevent this from happening. So it's all natural. It's not broken it permanently. But these guys are closing up. They are like the claw that you see in Tivoli that's getting bears, right? People have taken this and they have created games on it. So if you go back again, and you take the path generator under the advanced samples, number 2 from the top. Right there, yeah? Okay, so this is a more advanced sample. This is where we take soft bodies and put into the engine. So I've taken all these rectangles and circles, and I've made them stick together using joints. So he can move them around as he could before, but now they have a really bounciness to them. And I also made a bridge in the sample, and that's one line of code, for example. That's, you just tell where to start and where to end, and make a bridge, please, and it does that for you. It's that simple in Farseer. So if you go back again, and take the advanced dynamics, last one, and I'm sure some of you can recognize what we've done here. This is World of Goo, right? You can actually grab these guys in the head, and you can drag them, and it's breaking apart. And that's because all of these constraints that we have can be breakable. So you can make destructible worlds, you can make destructible bridges. So when something heavy rolls over the bridge, it's going to break and the guy is falling down. Again, this is...
The game here is to get it back to where...
Good luck with that.
That's why I give the control to someone else, because I'm just playing with it. He breaks it. So if you go back again, this sample is designed for the Windows Phone 7 also, so you can actually go down by pressing the down button at the left side there. Exactly. And take the racing car example, for example, the last one on the game samples. And you just, yes, and you just press the thumbstick to the left, sorry, to the right, and hold it down, the thumbstick. Yeah. That makes the car drive when he figures it out. And if he keeps driving, it's actually a racing game in 2D. So what we've done here is that we have implemented a camera that follows the car. And the wheels are actually real wheels. They are circles with friction on them. They have restitution and they have a speed. So when he holds down the thumbstick, it's going to accelerate and he can actually brake. And the car has a mass, as you can see. It's driving over here and it's falling down. So all of this is natural in Farseer physics engine. I've not done something special to make this game sample. I just tell it, I want a bridge there, I want a terrain there, and I want some more friction on the wheel. And this is what happens. We get a game naturally. So he's having too much fun and he really wants to make that jump, but he's unable to do it because the car is too heavy at the moment. It doesn't have enough speed. So as you can see, this is physics. This is physics done in a fun way. This is where we can create games using a few lines of code and we can create fun games at the same time. So only, again, your imagination is the limit, right? Come up with something new, come up with something interesting, make a game. And that's a whole nother story with the lasers. Yeah, exactly. It would be possible to. So I'm sorry I have to close down the sample now. So just to show that I'm not messing around with you, we have the exact same samples and we can run them on the Windows Phone 7. Now I put them down on my own Windows Phone 7 right here. And if anyone of you want to play around with it just to see how it feels, you can come up here and you can try it by yourself. We have a question?
What are the limitations in performance? Because obviously you can get a lot of objects moving around.
Yeah.
But what is sort of the limitations? How many objects would you sort of make alive and how many objects would you sort of make it in another way?
So the question is, what is the performance of the engine? How many objects can you handle at one time? And the answer is, it depends on the hardware, of course. But we try to make it as fast as possible by optimizing all the math, by optimizing all the algorithms, so that you can put in as much as you want to without getting lags, for example. But it really depends on the hardware. So for example, on the Windows Phone 7, well, we cannot have 1,000 things on the screen at the same time being simulated, but we can on the Xbox 360. And you can even have tens of thousands on the PC because it's even more powerful. So we are really pushing the limit on how much you can simulate using a physics engine. And have in mind that I've spent a lot of time optimizing this thing to make it as the fastest engine out there. And I really succeeded. So you can read all about this on my blog. It's coming up later. Okay, so this is the exact same samples as he was playing with. We cannot use the Xbox 360 controller here on the Windows Phone, but we can use the mouse instead. So this is simulating a finger. So we enable it to use the finger on the on the Windows Phone 7. So exact same samples, and they are simulated in the same way. Use the back button to go back. That's more logical than he was fooling around with the Xbox 360 controller. And to get back to your question, for example, in this sample we have a stack of objects, and that's really the worst case scenario of a physics engine, where all the stuff that you have in the engine is in a limited space. So we cannot simulate a huge stack of objects here on the Windows Phone 7. So we have limited to only a few, for example, 45 boxes on the Windows Phone 7, so it runs smoothly, so I wouldn't lag around right now. But on the Xbox 360 we have, for example, 100 instead, and on the PC we have 500. You can make a huge stack of objects and it gets a lot more fun. So we are limited by the processor inside the Windows Phone 7. But again, we can take a ragdoll, for example, and toss it around using our finger on the screen. You can even use the gestures so that you can flick this ragdoll around. And again, we have seen games like that. Get this ragdoll to fly as long as you can. Just flick it and it goes into the air and it hits bombs and it continues. And the goal is to get as long as possible. Simple games using, for example, Farseer physics engine makes it possible for you to make a game in a few days. So I bet within 2 days, a new guy who had never been able to code this stuff before can use Farseer physics and XNA, create a game, and put it on site on the Windows Phone marketplace.
By end of day tomorrow.
So Ben, I hope you are going to do that.
Yeah, absolutely.
Okay. So the first page up there, you've probably been hearing that for like 20 times today, but that's the app hub, and it's really important when it comes to both developing Silverlight and developing, Windows Phone 7 apps in general and XNA. Really, they have excellent resources. They have samples that you can download using XNA that tells you how to use the phone's capabilities and features. They have samples on how you can use particle engines inside XNA and performance enhancement and stuff like that. They even have a forum that you can go in and you can get help. The next site is Farseer Physics Engine. We are hosted on the Coplex site. And I'm not so active right now. I'm sorry about that, but I do have school and work, and I'm here. But we have some very dedicated contributors that are roaming around the forums all the time and helping out. They're great guys, so if you need help, go in there, ask, or send me an email, and I will sometimes redirect you to the forums, so go in there again, or I will help you out personally. And I have my blog, where I write about performance, I write about physics in general and XNA, stuff like that. It's really a good read if you are not, if you're into more advanced stuff in XNA and into more advanced performance enhancements to your game, for example. It is possible to do extreme games that use a lot of processing on the Windows Phone 7 using some of these articles that are written here. Farseer Physics Engine is a testament to that. We've been able to run huge amount of particles, for example, inside the Windows Phone 7 device. This little processor right here can handle a lot if you do it the right way. So are there any closing questions? I have a question right there. So the question is it possible to do this processing in the GPU instead? It's a good question, because the GPU is a lot better at floating points than the CPU. So that would in theory mean that we can get more performance out of an engine like this using the GPU. The answer to that is we have tried and we have failed. I've been trying to do it all on the graphics card instead of in the CPU. And it's really hard to synchronize all the data. It's really hard to maintain this code because it needs to be a little more low level. And my time was limited, so we did not do it, but it is possible. I've been, sorry? Yeah, we can actually use some of the APIs out there to do this stuff. And we also tried that, but it was hard to do. I have been a developer on something called Mercury Particle Engine, where we do exactly that. We took all the stuff that is calculated on the CPU and took it over to the GPU instead, and we got a 10-fold increase in performance. So when you can offload stuff to the GPU, if it's not busy doing the graphics at the same time. Other questions? Okay.
3D? Did you talk about 3D?
The question is 3D, 3D physics. We have thought about building a 3D physics engine, but what we have done here is that we actually took one of the more popular engines on the internet called Box2D, converted it to C#, and it's 2D only. So if you were to write a 3D wrapper for this, it would take a lot of time, and we will have basically 2 code trees that we need to maintain. So I would recommend that people who need it 3D either display the graphics in 3D and use a 2D engine, just like Toy Story Bike, or they use a 3D engine. Because we are mainly focused on 2D, we're really good at it, so we like to keep the focus there. Well, guys, that was my presentation for today. I hope you liked it.